Introduction. We have seen that a triangle has 6 parts, 3 sides and 3 angles. But to construct a triangle, you need to know only 3 parts. So we can construct a triangle using the SAS, ASA, SSS and RHS axioms. Now a question arises whether 4 measurements would be sufficient to draw a unique 4-sided closed figure, namely a quadrilateral. As a quadrilateral has 8 parts, we need to know at least 5 parts to draw a quadrilateral. Objectives. At the end of this lesson, you'll be able to construct a quadrilateral, construct a square. Construction. Constructing triangle ABC. To construct a quadrilateral, given 4 sides and a diagonal SSSSD case, let the given measures be AB is equal to 4.5 cm, BC is equal to 5.6 cm, CD is equal to 5.9 cm, DA is equal to 5.2 cm, and diagonal AC is equal to 6.8 cm. The 2 triangles we can construct to complete the quadrilateral are triangle ADC and triangle ABC. Constructing triangle ADC. Draw DC, which is equal to 5.9 cm. With C as center and radius 6.8 cm, draw an arc. With D as center and radius as 5.2 cm, draw another arc to cut the previous arc at A. Join CA and DA. Constructing triangle ABC. With C as center and radius as 5.6 cm, draw an arc on the other side of AC. With A as center and radius as 4.5 cm, draw another arc to cut the previous arc at B. Join CB and AB. Then ABCD is the required quadrilateral. When 3 sides and 2 diagonals are given, construct a quadrilateral ABCD, given that AB is equal to 5 cm, BC is equal to 7 cm, AD is equal to 4 cm, and diagonal AC is equal to 9 cm, and diagonal BD is equal to 6 cm. Steps. Draw AB, which is equal to 5 cm. With A and B as centers, and 4 cm and 6 cm as radii respectively, draw arcs to cut each other at point D. Join AD and BD. With A and B as centers and 9 cm and 7 cm as radii respectively, draw arcs to cut each other at C. Join AC and BC. Join also DC. ABCD is the required quadrilateral. Construction. To construct a quadrilateral, given 3 sides and 2 diagonals SSSDD case, let the sides be AD as 4.2 cm, DC as 6.5 cm, CB as 5.8 cm, and the diagonals be CA as 6.9 cm, BD as 7.2 cm. The 2 triangles we can construct to complete the quadrilateral are BCD and ACD. Constructing BCD. Draw DC as 6.5 cm. With D as center and radius as 7.2 cm, draw an arc. With C as center and radius as 5.8 cm, draw another arc to cut the previous arc at B. Join CB and DB, constructing ACD. With C as center and radius as 6.9 cm, draw an arc on the same side of DC. With D as center and 4.2 cm radius, draw another arc to cut the previous arc at A. Join CA and DA. Join AB. Then ABCD is the required quadrilateral with diagonals AC and BD. Given two adjacent sides and three angles. Construct quadrilateral ABCD. Given that AB is equal to 7 cm, AD is equal to 4 cm, angle A is equal to 70 degrees, angle B is equal to 50 degrees, and angle C is equal to 140 degrees. We cannot draw this quadrilateral if we do not know angle D. We can find angle D. Angle D is equal to 360 degrees minus angle A plus angle B plus angle C, which is equal to 360 degrees minus 70 plus 50 plus 140, which is equal to 100 degrees. Step 1. Draw the line segment AB is equal to 7 cm. Draw angle A is equal to 70 degrees using a protractor. With A as center and radius as 4 cm, cut an arc on the line. At B, draw an angle 50 degrees. At D, draw an angle of 100 degrees with a protractor. Let the arms of these angles meet at C. ABCD is the required quadrilateral. Construction. To construct a quadrilateral, given three angles and two included sides, ASA case. Let the given angles be angle A as 75 degree, angle C as 85 degrees, angle D as 68 degrees, and the given sides be AD as 6.1 cm, DC as 7.5 cm. Here also we can construct the quadrilateral directly without dividing it into two triangles. Construct AD as 6.1 cm. At D, draw angle ADX as 68 degrees. With D as center and radius as 7.5 cm, cut off DC as 7.5 cm on the ray DX. At A, draw angle DAY as 75 degrees. At C, draw angle DCZ as 85 degrees. Let AY and CZ intersect at B. Then ABCD is the required quadrilateral. Given three sides and the two included angles. Draw quadrilateral ABCD. Given that AB as 5 cm, AD as 4 cm, BC as 6 cm, angle A is 100 degrees, angle B is 120 degrees. Steps. 1. Draw AB as 5 cm. 2. At A, draw an angle 100 degrees, and at B, draw an angle is 120 degrees. 3. Mark of distance. AD as 4 cm and BC as 6 cm. 4. Join CD. ABCD is the required quadrilateral. Construction. Construction of a quadrilateral, given three sides and two included angles, SAS case. Let the given sides be AD as 5.6 cm, DC as 6.2 cm, CB as 4.9 cm, and the given angles be angle D as 108 degrees, angle C as 120 degrees. In this case, we do not need to construct the quadrilateral by constructing two triangles. Draw DC as 6.2 cm. At D, draw angle CDX as 108 degree. With D as center and radius as 5.6 cm, cut off DA as 5.6 cm on the ray DX. At C, draw angle DCY as 120 degrees. 5. With C as center and radius as 4.9 cm, cut off CB as 4.9 cm on the ray CY. Join AB. Then ABCD is the required quadrilateral. Constructing special quadrilaterals square. Draw a square of side 5 cm. We know that all the angles are right angles and all the sides are equal in the case of a square. Given one side length is equal to 5 centimeters. Steps. Draw a right angle with a protractor or compass and ruler at a point A. Set the compass to 5 centimeter and cut off sides AB and AD of the square along the arms of the right angle. With B as center and with the same radius, draw an arc. With D as center and with the same radius, draw an arc to cut off the arc drawn. Join the point C, where the arcs meet to the ends B and D of the sides AB and AD to form the square. ABCD is the required square. Summary. Let us summarize what we have learned. We construct a quadrilateral if we know 4 sides and a diagonal, 2 adjacent sides and 3 angles, 3 sides and 2 diagonals, 3 sides and 2 included angles. Introduction.
Good morning, sir.
Good morning, students. Please sit down. Today we will start a new lesson, rational numbers. You will know how rational numbers are the numbers of everyday arithmetic and why are they called rational. So let us start a lesson. Objectives. At the end of this lesson, you'll be able to distinguish between natural numbers, whole numbers, and integers. Define rational numbers. Learn the addition, subtraction, multiplication, and division of rational numbers. Discuss the role of 0 and 1 for rational numbers. Explain additive inverse and multiplicative inverse of rational numbers. Find rational numbers between any two given rational numbers. Whole numbers are simply the numbers 0, 1, 2, 3, 4, 5, and so on. There are no fractions. Natural numbers are the positive whole numbers except 0. Integers are like whole numbers, but they also include negative numbers. So integers can be positive, negative, and 0. Students, what about 1 by 2? Is it a whole number, natural number, or an integer? You can see 1 by 2 lies between 0 and 1. We call it a rational number. Come along to know more. A rational number is a number that can be written as a simple fraction, that is, as a ratio. So, a rational number looks like this, that is, P upon Q. Remember, Q cannot be equal to 0. Can you tell which of these numbers are rational? Yes, all of them are rational. So, rational numbers are simply the numbers of arithmetic. Sometimes the rational number can be like that. Do you think that it is in simplified form? No, it can be further simplified. But how? Here we can divide the numerator and denominator by 5 to get 3 by 5. This is the simplest form. So students, remember we can simplify the fraction by dividing the numerator and denominator by a common factor. How to add rational numbers? Hey, it's easy. Before we add, keep in mind the rational numbers should have the same bottom number, that is, both the rational numbers must have common denominator. The easiest way to do this is to multiply both parts of each number by the bottom part of the other. Here is an example of addition. We will add 5 by 4 and 1 by 4. See, the denominators are already the same. Now add the numerators and put the answer over the same denominator. This fraction can be further simplified to 3 by 2. Subtraction of rational numbers is same as the addition. Before subtracting the rational numbers, always look for the common denominator. If it's not common, multiply both parts of each number by the bottom part of the other. Here is an example of subtraction. we will subtract 1 by 7 from 5 by 7. We know denominators are already the same, so subtract the numerators and put the answer over the same denominator. Now we will study multiplication of rational numbers. This is the easiest one. To multiply two rational numbers, just multiply the numerators and denominators separately like this. Here is an example. We will multiply 1 by 3 and 3 by 5. First of all, we will multiply the numerators. Now we will multiply the denominators. Now this fraction can be further simplified to 1 by 5. Division of rational numbers is again very simple thing to do. First of all, flip the second number over and make it a denominator. After that, do a simple multiplication. Here is an example. We will divide 1 by 4 and 1 by 6. Now we will turn the second fraction upside down so that it becomes a reciprocal. Multiply the first fraction by that reciprocal. This fraction can be further simplified to 3 by 2. Here we have added a 0 to a rational number. What did you notice? When we add 0 to a rational number, the sum is always again rational number. For this reason, 0 is called the additive identity of rational numbers. Now check it out, the multiplication of a rational number with 1. What did you observe? When we multiply a rational number with 1, the product is always again that rational number. For this reason, 1 is called the multiplicative identity of rational numbers. You may have come across negative numbers while studying, isn't it? Is -1 the negative of 1? Yes, it is because 1 plus -1 equal to 0. So we say that -1 is the negative or additive inverse of 1. Likewise, for any rational number, say 3 by 7, -3 by 7 will be its additive inverse. Just think, by which rational number would we multiply 7 by 19 to get the product of 1? Obviously, it's 19 by 7 so as to get the product 1. So we say that 19 by 7 is the reciprocal or multiplicative inverse of 7 by 19. Did you know that there are infinitely many rational numbers between any two rational numbers? Now we will learn about it. Let us find a rational number between these two rational numbers using a mean method. So we can say 3 by 8 lies between 1 by 4 and 1 by 2. First of all, we will find the sum of these numbers, which comes out to be 3 by 4. Now divide this sum by 2. We know division flips the second number and sign changes to multiplication. Let us check your knowledge. Drag and drop the correct option into its respective place. Summary. Let us summarize what we have learned. A rational number is a number that can be written as P upon Q, where P and Q are integers and Q is not equal to 0. Rational numbers are commutative and associative under addition and multiplication. 0 is the additive identity for rational numbers. 1 is the multiplicative identity for rational numbers. The additive inverse of P upon Q is minus P upon Q and vice versa. The reciprocal or multiplicative inverse of P upon Q is A upon B if P upon Q into A upon B is equal to 1. For all rational numbers A, B and C, A into B plus C is equal to AB plus BC and A into B minus C is equal to AB minus BC is known as the distributive property. Rational